1.4. We are only doing the first half of 1.4 today because it is a total of 10 examples. So we're going to do 5 today, and then we're going to do 5 tomorrow. 1.4 is graphs of functions. Okay, so you were going to be given.
Excuse this interruption. Kendall Barber, please come to the front office. Kendall Barber.
You are going to be given graphs where they say find the domain, the function values for f negative 1, f of 2, and the range. Okay? So how can I find the domain of that function right there? How can you find the domain of that function? Time out. No, there is a domain of this function because it's graphed a certain way. What do you notice about this? What does domain mean? What are you looking for when you're looking for the domain? How far it travels on the x-axis. There is definitely 2 stopping points on there. Where would they be?
-1 and 4. -1 and 4.
-1, +4. -1 has a solid dot here. Do you see this? +4 has a what? An open circle. Okay? That we're going to start writing our domains and ranges in interval notation. Okay? Those things tell me stuff. What, Morgan? Okay. That tells me something. If it is closed, am I going to use a bracket or a parenthesis? Bracket. So it's -1, and if it's open, what am I going to do? Parentheses. So it's -1 to 4 is my domain. That's how I read the domain on this type of graph. Okay? So when it gives you a specific one like that, this is called interval notation, and you are writing it in interval notation. Okay? Now, it says the function values of f of -1 and f of 2. What do I have to do to solve that?
Plug it in.
Plug it into what? Well, y equals f of x, right? But
Don't you have to make it,
guys,
we're doing this one, you're doing the blue one?
I'm doing this.
Oh, never mind.
So if my function is y equals f of x, first of all, look at this graph. When I'm plugging -1 in, what does that mean -1 is? My x or my y value? Or x. Is there someplace on there where it tells me what my y value is for when it's -1?
Yes.
What is it?
-5.
Yes, -5. Good. You just read the graph on this one. So f of -1 equals -5. Okay, what about f of 2? 4. Okay, the graph told us what it was. Okay, because there's no equation to plug it like x squared, whatever. There's no equation like that. Now, the range. The range is what?
Bottom. Y.
Y-axis is how far it travels on the y-axis. So, do I have a stopping and starting point for range?
-1 and 4.
-5
4.
and
4.
4. And both of those are what? Brackets or parentheses?
Brackets.
Brackets. So it's -5 to 4. Okay? That's some stuff you're going to have to do off of just looking at a graph that they give you. You're going to have to find the domain, the range, and values.
Wait, how do you know which one to put first?
Because your smallest always goes first, like your
Doesn't always
lowest
go
point
bottom to
and your
top?
highest point goes second. Your furthest point to the left goes first, your last point is to the right, okay? That's how. Now, finding the domain and range of the square root of x minus 4. How do I find the domain of that?
You have to set it,
Not equal to 0.
inequality.
You have to make an inequality when it is a radical, so greater than or equal to 0. Now from there, what do I do? You add 4, right?
Yeah.
Add 4, add 4. So x is greater than or equal to 4, okay? So that is my range, yes? What is your domain of this? What is my domain?
Darn.
Yes, all real numbers.
I thought you were just saying. I said, oh, darn.
You said Okay. Refresher. Do you guys remember what the vertical line test is?
I remember that.
Yeah, if it goes
I
through,
don't.
if you draw a vertical line and it goes through it once, it's a function. If it goes through it twice, it's not a function. Okay, pretty simple. Okay, then we're gonna look at functions with increasing, decreasing, and constant. You're going to have to be able to list all three if they're happening in one graph. Or if two of them are happening, you're gonna have to be able to tell me all those things. So increasing functions, okay, when something's increasing, that means it's hit a turning point and now it's going up, okay? So when x1 is less than x2, it implies that the function of x1 is less than the function of x2 when you're increasing. When you're decreasing, x1 is less than x2, but it implies that the function of x1 is greater than the function of x2. So I've hit a changing point, I'm decreasing. Something that's constant means on my graph it's just going like this. It's just staying even, okay? There's no change yet. And that means that the function of x1 is equal to the function of x2, okay? So then we get to come over to three different graphs, okay? And it says determine the open intervals on which each function is increasing, decreasing, or constant. Okay? On the first one, what do you think is happening? Do you have increasing, decreasing, constant, all three? What's going on?
Increasing.
And constant.
Okay. Okay, possibly. If it is, what do you, like, what, give me an example of what's going on there. It's an x cubed, it's a cube root function, yes? So it makes those functions where it goes like one way this way and then one way down, yes? Where's my turning point of this graph? 0, 0. 0, 0 is my turning point. Here it starts to head up, here it starts to head down, okay? So it might appear that there is an interval in which this function is constant, like you said. But you can see that if x1 is less than x2, then x1 cubed would be less than x2 cubed. So what it's saying is, yeah, so there isn't a constant, even though it appears that this is a constant. That's a turning point. Okay, constant's going to be more drastic.
Like number, for example.
Yeah. Okay, which implies that the function f of x1 is less than the function of f of x2. So the function is increasing over the entire real line. So it's increasing. What about this function, x cubed minus 3x? What's happening there? Increasing and decreasing? The function is increasing on what intervals?
Negative.
Increasing. Okay, so increasing, it starts to increase, right?
1.
And it starts to decrease, okay? So let's talk about this. Increasing happens here, okay? It happens basically right here is the turning point for it to increase. What point is that?
1 negative.
1 negative.
1 negative 2. So the way that we would tell or say what is happening with increasing, okay, to write it in interval notation, we have to look at what the x is at that point. The x at that point is 1, correct? And then it's going to increase positively the whole time, yes? So my increase, when I write it, is 1 to infinity. Okay. Now, what about my decrease? Uh-huh. My decrease starts here, and my x value there is -1, and it's decreasing to infinity. I read that wrong.
Oh, I remember this.
I did write it
This is
wrong.
super
It
easy.
has to go
Never
this way.
mind.
It goes negative infinity.
This is
to
anything I
negative
understood
one.
last year.
What's the increase of function number 1?
The increase of function number 1
Oh, I like
is
this.
true for any value, so you can put anything in there. Yeah.
Is that the decreasing interval?
This is increasing, that's the decreasing interval, yes. Okay?
It's like that here.
Because decreasing starts here and it's going down forever in negative infinity. and the turning point was at -1. So you have to list it in order of what's less to what's greater. Does that make sense? Okay. Now,
But I kept
over
finding
here, we have another function, and this one is like one of those fun ones that we get to put in our calculator with all those parameters, okay? That's what we need to ask. What is happening in that function? All three. All three are happening, okay? It increases from here to here. It's constant from 0, 1 to 2, 1, and then it decreases after 2, 1. So now we have to come up with intervals for that. Okay? What's the increasing interval? Where does it start at?
Infinity.
Negative infinity. Okay? Where does it end the increase? At what? At 0, 1? At 0? Because that's my x? Good. Now, my decrease. Okay? My decrease. Where does my decrease start?
1.
At 2.
2.
2. I use my x. And my y would be what?
Positive infinity.
Negative infinity.
What?
Because it's going down. Negative infinity. Or, wait a second, let me think about that. To infinity. My decrease is just infinity. I can plug anything in. Now, what's my constant? What's your constant? 0 to 2. From x to x. 0 to 2. Okay. So that one has all three. You're going to have to do that tonight on your homework. And then the last thing that we're going to have to do on our homework is do relative minimums and maximums, but we're going to use our graphing calculator for that. Okay? So a relative minimum and maximum is pretty simple. Every time there's a turning point, you either have a minimum or you have a maximum. Okay? If this graph, this has 2 minimums and 2 maximums. There's 4 turning points. Okay? So every time you have a turning point, you have a minimum or a maximum. I need you to plug this into your graphing calculator so we can figure out what our minimums and maximums are, please. So you're going to plug in 3x squared minus 4x minus 2. And I bet if you use a standard viewing window, you'll be able to see it just fine. And then you press graph.
Trace.
Okay?
Something's wrong with my calculator.
Why? What's wrong with it?
It's having a seizure.
Okay.
You should take it to the doctor.
Now, once you get that graph, what type of shape did you get?
No, but
A parabola. A parabola.
Oh, yeah.
What?
Aerial.
A parabola. Does it have a maximum or a minimum? A minimum, okay? So, how we're going to find the minimum is you are going to press second and the trace button, second calc, okay? Because it's in blue and calc. Now, look, it says calculate. What does it have as an option?
Minimum.
So you're going to hit minimum, okay? And it's going to take you, it should take you to the bottom of that. If it doesn't, mine took me to x equals 0, y equals -2,
That's some money.
okay? So clearly it's not exactly at the minimum there. That's where the turning point starts. So I just go ahead and scroll down a little bit, and I get something around the lines of 0.64 for x and -3.3 for y.
what button was that?
Yeah.
The second.
Second trace. Second
0.6,
trace.
0.64 and then -3.3.
Yeah, so I got 0.64 and then I got -3.33, yeah?
Yep, yep.
Okay, so if your answer's not exactly like the book's answer, it's okay. It's gonna be a little off. These are decimal answers. They're gonna be pretty precise. Don't stress about it,
Can
okay?
you stick with whole numbers?
As long as it's close, yes. Okay, so then that is my minimum, correct? And that's all that you have to do on problems like that. Okay, you just have to list the minimum and maximum. If it had more turning points, then you would go and list every minimum and every maximum. Does that make sense?
Oh.
Yes, Jenner?
Wait, so how do you know if it's a minimum?
Because it's at the bottom, like, but this graph should look something like this, right?
Yes.
So that's a minimum because it's at the bottom.
Oh, so if it were like
If it was a mountain, it would be a maximum, yes. Okay, that's how. That's what you're working on today. Tomorrow we will continue this.
Be nice.